All right, so in this segment, I want to talk about how to simplify a rational expression or a rational function. And the name of the game here is that you want to factor everything in sight. So completely factor the numerator and denominator, and then cancel out any factors of 1 that you see. Okay, so if a, b, and c are polynomials and c is not equal to 0, then if you have a times c divided by b times c, that's equivalent to a over b. Okay. Because essentially we're crossing out a factor of 1, okay? So c over c is considered to be 1. Okay, so I've got this example. So if we had r of x is equal to x minus 4 over x squared minus x minus 12, it's a rational function, right? The numerator is fully factored, but if we factor the denominator, right, we're looking for factors of negative 12 that add to negative 1, and positive 3 and negative 4 do it, right? 3 minus 4 is negative 1, and 3 times negative 4 is negative 12. Okay, so we factored that. And then we notice that the numerator and denominator have a common factor, don't they? They have a common factor of x minus 4. So that's essentially a factor of 1 that we can cancel out. If you end up canceling the entire numerator like that, it doesn't just go away, right? There's actually a 1 there. You know, you can think about this as 1 times the quantity x minus 4, if you will. Okay, so we end up with 1 over x plus 3. And we also have to say that x can't be 4. That domain restriction is actually very important because otherwise the 1 over x plus 3 is not equivalent to the function that we were originally given, right? Because the function that we were originally given had that x minus 4 as a factor in the denominator, which means that 4 can't be part of the domain. And of course 4 can't be part of the domain because if we stick 4 into that factor we get 0, right? We can't divide by 0. That's the whole deal. Okay, so I would graph this in Desmos, but I don't know if I'd even be able to make a point because it's sometimes really hard to see. But when you have a function like the original r of x equals x minus 4 over x squared minus x minus 12, if you graph that in Desmos and you also graph 1 over x plus 3, what we simplified this to be, you'll get the same graph. The only difference, which is really hard to see, is that at x equal 4, there's just going to be a little hole in the graph, kind of like that, right? There's just nothing there. It's not an asymptote. The graph's not going to go berserk there or anything. When you cancel a factor out like that, that's what happens. So, but the graph of 1 over x plus 3 also has to have that same hole at x equal 4. And so that's why we have to say, well, x can't be 4. Otherwise, they're not quite the same function. So that's why that domain restriction is so important. Okay. Also, if this is kind of weird for you, this whole factoring business, and you're like, well, what is this? How do I know what to cancel and things? Kind of think about it. I would encourage you just to relate it back to just a regular fraction without the variables. So like the 4 and the 12, I'm just going to cut out the variables for a minute. Let's just look at that. 4 twelfths. How would you reduce that? Okay, if you were going to reduce that fraction. Well, most of you would say, okay, well, I can divide that by 4, the numerator, and I can divide the denominator by 4, and I get 1 over 3, right? Okay, well, what did we really do there? So I'm going to take 4 over 12. If I have 4 down here, 12 splits into 2 factors, right? 3 times 4, okay? And 4 over 4 is 1, right? It's a factor of 1, okay? And remember, you still have a 1 in the numerator there, okay? So essentially, it's the same idea, right? What we got with the variables, too. But that's the idea. You're really just splitting things into factors and canceling out factors of 1 as you see them. Okay? All right, so let's get a little bit more practice with this. So we're going to simplify each function and, if applicable, write the restricted domain. Okay, so in this first one, we have f of t is equal to t squared minus 3t minus 4 all over t squared plus 9t plus 8. Okay, so if we're going to simplify that, we need to factor like crazy, right? Both the numerator and the denominator. So now, if factoring is something that you are rusty with, there are lots of places that you can go to get some practice with that. Our own textbook, the online version of it, will have sections that will help you refresh some of this material if it's rusty for you. So in the numerator, t squared minus 3t minus 4. Okay, so we're looking for factors of negative 4 that add to negative 3. Okay, So I'm thinking negative 4 and 1, right? So t minus 4 times t plus 1 is what we'll have. Okay, because negative 4 plus 1 is negative 3, and negative 4 times 1 is negative 4. You can always FOIL out whatever you get, make sure you get what you started with, right? But the middle term, you're going to have t minus 4t, right, which is negative 3t. Okay, so, and in the denominator, factors of 8 that add to 9, well, 8 and 1, right? So I'm going to have t plus 8 times t plus 1. Okay, all right. Now I can cancel that factor of t plus 1 out. And when I do that, remember what I said, it's just a little hole in the graph at t equal negative 1. So you're thinking about the value of t that makes that factor of t plus 1 0, and it's negative 1, right? So t can't be negative 1. Okay. Now, if you just look at t minus 4 over t plus 8, you wouldn't see that restriction, right? So that's why we're calling it a restricted domain. So you want to list the domain restrictions that aren't obvious, right? The obvious one is going to be that t can't be negative 8. But we also know that t can't be negative 1 because it couldn't be negative 1 in the original function that we were given. Okay. All right, so let's try this other one. H of x is equal to 3x plus 15x all over x to the fourth minus 25x squared. Okay, so let's simplify that. In the numerator, I can factor out 3x, right? And that will leave x plus 5, right? We distribute the 3x back through. We get 3x squared plus 15x. Yes. Okay, and in the denominator, I can factor out an x squared, right? So that will leave x squared minus 25. So we have x squared times the quantity x squared minus 25. Okay, now there are some things that I've noticed. Before I cancel out any factors of 1, I'm just going to take this one step further and factor completely here. So I'm going to leave the numerator as 3x over x plus 5. And in the denominator, I'm going to have x squared. X squared minus 25 is the difference of squares, right? So I'm going to have x plus 5 times x minus 5 when I factor that. Okay, so let's take a look here. X plus 5 over x plus 5, that will go away. It's a factor of 1. And then also what happens with this x over x squared, right? I have 1x upstairs and I have 2 of them downstairs. So this one upstairs will go away and this one down here will become 1, right? So the end result here will be 3 over x times x minus 5. Okay, and what are any of the hidden domain restrictions? Well, x can't be negative 5, right? Because if it's negative 5, okay, right, because we canceled out that factor of x plus 5. So if x is negative 5, that would make that factor 0, right? Okay, so the other restrictions of x can't be 0 and x can't be 5 are visible in our final result, right? But the x equal to negative 5, that one we can't really see in our final result. But x can't be negative 5 in our original function, right? So we have to make sure we state that. Okay.